Hi, this is Scott. What we're doing today is we're going to be looking at running one approach to validating a stepwise regression using a teen survey data set with SPSS. When doing stepwise regression, it's really critical that we conduct an independent validation of our results because by its nature, stepwise regression kind of takes advantage of chance. So we are going to try to make sure that the results that we have internally validate with our data set. So in this case, we're going to try to be predicting standardized math scores by looking at reading scores, vocabulary scores, the gender of the respondent, and the race of the respondents. Both gender and race are dichotomized, so we won't have to create dummy variables for them. The approach that we are going to take to running the stepwise regression and then validating it is initially we're going to run the stepwise on all 300 of our cases. Then we are going to take a random sample of 75% of those cases and run the stepwise regression again. And we're going to see if the same variables that loaded on our full sample also load on our training sample or the 75% sample. After we do that, we're also going to see whether or not the amount of variance that's accounted for, that is the R square, is the same or equivalent for our validation sample as it was for our training sample. So we have a number of different procedures that we have to go through. So the first thing that we're going to do is we're going to go and run the initial stepwise regression on all of our cases. So we go to Analyze, Regression, Linear, and I've already populated our dependent and our independent variables. You can see that the scaled math score is the dependent variable, and we have vocabulary score, reading, gender, and ethnicity. Okay? You see that I have indicated that stepwise is the method that we are going to be using. We don't have a selection variable at this point, so make sure that this is empty because we want to include all of the variables. We're going to make sure that the statistics that we have for this include all of our critical statistics, although we're not going to pay attention to them for this illustration. I just want to make sure that everybody is in the habit when we're doing hierarchical or stepwise regression that we also ask for R-squared change, and that we always ask for model fit, descriptives, collinearity diagnostics, and case-wise diagnostics. We are also going to go to options, to go to plots and make sure that we have set up to test our critical assumptions. So we make sure that z-resid is in the y-axis and z-predicted is in the x-axis, and we have checked both of the normal probability requirements here. At that point, we click OK, and this will give us a stepwise regression result. And what I'm going to do first of all is I'm going to see how much R square is accounted for. So this is telling us that there were 4 variables added in, 4 steps, which means that all of our variables did get entered. Our R squared is about 49.6%, so almost 50% of the variance in those standardized math scores are accounted for within our prediction equation. When we adjust it for our sample size, we lose a little bit, so we're down to about 48.9%. We can look to see how the variables entered. We can see down here where it lists the coefficients. You can see that the first variable that was entered was reading, then gender entered in the second block, and then vocabulary entered in the third block, and finally race and ethnicity entered. You can see from these significance values that all 4 of these variables were statistically significant. They would not have entered the equation if any of their probability values were less than 0.05. That is the default level with SPSS for entering into the stepwise regression. So we see that all of the variables that we had included were significant. The next step that we have is excuse me, we're going to go back to our data, and I have already filtered, I've already created a filter variable that has identified 75% of the cases as filter value 1, and the remaining 25% of cases have a filter value of 0. We have talked about how to do these, creating these filter variables in other videos, so I skipped over it for this one. We are now going to go and we're going to run a stepwise regression again on 75% of our cases. We're going to run the exact same regression that we just ran, but we're going to run it on just the 75% of cases. So we go to regression, linear. In this case, we're going to use the selection value, right? So we're going to go down and we're going to send the selection variable over here, and we're going to run this on a value of 1, which again represented our 75% of cases that have been randomly selected. Everything else is going to stay the same, so we're going to click OK. We now have all of the analyses done that we need in order to judge this, the satisfaction of our equation. The first thing that we're going to look at is whether or not the variables that we had intended to enter actually did enter. So we go down here and we look at our model, and what we see in this case is reading entered first, gender entered next, and then vocabulary score entered. But in this case, in these 75% of cases, we don't have race entering as a significant variable. You'll see that it was actually excluded here in that last run because the significance value was less than 0.05. You can see that at the end it was only 0.411, so it did not enter the equation. The bad news is that that tells us that our equation did not validate. Okay, so at this point we are stuck with a concern that we might only have 3 predictors that are common. It runs into a challenge of whether or not the stepwise regression is appropriate in this case. The other thing that we will typically look at when we do a validation like this is we'll go back up and we will look to see whether or not there is a significant decrease in the R-squares between the training group, that's the 75% of cases, and the validation group, which is the 25% of the cases. So when we look at what happened with our 75% of cases, you can see that we have an R-square of about 0.514, or about 51%. Okay? What we have to do to figure out what that R-square would be for the validation group is we have to get this multiple R. This is the correlation between the predictors and the dependent variable, and it turns out to be about 0.645 in this case. When we compare the 0.645 squared, which turns out to be about 42%, we compare that 42% to the 51% that we found for the training group, we have to conclude again that our models don't validate. If the R-square for our validation sample is more than 2% lower than our R-squared for the training group, we have to conclude that the stepwise regression does not validate. So in this case we have 2 problems. We have the problem that the same variables don't validate between the full model and the training model, and we also have the problem that the R-squares, the amount of variance that's accounted for between the training sample and the validation sample are not within 2%. So we are left to conclude that in this case the stepwise regression does not validate, and we would need to figure out another approach to dealing with our challenge. For example, perhaps considering eliminating race from the model. But even when we eliminate race from the model, we know that we're going to be in trouble in that the 25% will not necessarily equate to the 75%. This highlights one of the challenges of using stepwise regression.